Good morning, dear students. One of the students have asked me a doubt. The doubt was, Sir, the doubt was, all of we know that the formula for magnification is m equals to hi divided by ho equals to minus v divided by u. Sir, why? Sir, why? Okay, only negative sign. Sir, why only negative sign to the v by u quantity, not it is for hi by ho quantity? So was the doubt. This was the doubt. Okay, so today I'm gonna give you the answer. So one of the students have commented in YouTube, right, this as a doubt, right? So it's my responsibility to give you the answer. So today I'm gonna give you the answer in the form of another video, right? Now see here, let us consider a concave mirror. Okay, first of all, so before that we should have two conditions. We should know two conditions. We have two conditions, and those conditions you should know. If m equals to, you are getting negative value. If m value you are getting negative, so the image is, okay, image is, right, inverted. If an image is inverted, commonly you should remember that it will be real. Okay, and the next thing is, if we get m value positive, then the image will be real. Sorry, the image will be virtual. It is virtual. So remember, all the virtual images will be erected. Okay, right? So these conditions, these two conditions, you should have in mind. This is not there, you will not have clarity. Okay, remember, if m value is negative, image will be inverted and real. If m value is positive, okay, it will be virtual and erected. Okay, right? So let's go to next step. Yeah, let us consider an example. That is, I am considering a concave mirror, right? So this is the concave mirror. So principal axis, pole, this is midpoint pole, after that focal point, and after that center of curvature. So I'm gonna locate the object beyond C. So let us consider a ray, right, which is parallel to the principal axis, is incident on the mirror at a point. Now remember, if an incident ray is parallel to the principal axis, that reflected ray will pass through the focal point, right? Next, consider one more ray which passes through the, right, focal point. This is one more incident ray which is passing through the focal point. Then the reflected ray will be parallel to the principal axis. Then this is the point of intersection of the both the reflected rays. This this will be the point of, this is the point of intersection of both the reflected rays. Now this is the position where the image has formed. So if the object is, let us suppose the height of the object as ho and the height of the image as hi. Okay, right, according to sign convention. Now here we have necessity to look at sign convention. Now you see here, the distance from pole to focal point is focal length. Distance from pole to image is image distance. Okay, and distance from pole to object is object distance. Okay, u. We should know the sign convention to these quantities, that is u, v, f, okay, radius of curvature r. So how to write the sign convention. So for that our reference direction is the direction of instant light, right? So this is the instant light. The instant light is traveling from object to mirror. Okay, so the instant light is traveling from object to mirror, right? So let us suppose I'm gonna denote the direction of instant light with arrow mark and labeling it as L, because light, L stand for light. Okay, so this is the direction of instant light as the light is moving from object to mirror. Okay, now I should know the sign convention for the distances, that is focal length, image distance and object distance. So remember, when we are measuring a particular distance, okay, of particular quantity, okay, when we are measuring a particular distance, always we should start to move from pole to the destination. Means if I want focal length, I have to start to move from pole and reach focal point. Okay, if I want image distance, I have to start from pole and move to the image. If I want object distance, I have to start from pole and reach object, right? So this is the direction always I have to follow while we are measuring any distance in the case of a mirror, either it is concave mirror, convex mirror or plane mirror, whatever it is. Now if I want image distance, I have to move from pole to image. Means in the case of image distance, I am moving opposite. If I take V, I am moving like this, that is pole to image. So this my traversal direction and the instant line direction both are opposite. So if a distance is measured opposite to the instant light direction, that quantity should be taken as negative. Now next thing, let us observe object distance also. So object distance, see, I have to move from pole to object. So here also the sign convention for object distance, see, direction or both are opposite. See, instant light and my traversal, so both are opposite, so negative. Okay, now one more condition you have to remember. If, right, the distance is measured, if any distance is measured above the principal axis, if any distance is measured above the principal axis, that distance should be taken positive. And if any distance is measured below the principal axis, that distance should be taken negative. According to that convention, here HI is negative and HO is positive. Now let us substitute these V, U, HI and HO in the magnification formula. So how? So first let us consider, actually our original formula is M equals to HI by HO, okay, and equal to minus V by U also there. So that's why I am writing separately M equals to V by U. Here what I am gonna do, I'm gonna take just minus sign. So since the student has asked why it is not, why negative sign for, okay, why the negative sign is not for HI by HO quantity, so that's why I'm gonna take negative sign to the HI by HO quantity, and I'm gonna prove that this is wrong by taking like this. Okay, so how? So initially I have told two conditions, those conditions you have to remember. Okay, by substituting the sign conventions for HI and HO from the previous diagram, that is from here we have to take the sign convention for V, U, HI, HO and substitute in this formula. So what will we get? Now M equals to, so minus is common, that is their default, whatever we have taken we have assumed, and say sign convention for HI, height of the image, minus, so are taken negative, and sign convention for object height, that is HO, So this is HO, that is positive. So what happened is here minus into minus plus, you know that. So you'll get, so M equals to plus HI by HO. Okay, so we got positive value, we got here positive value, so when magnification is positive, what will be the image? Image will be erected, image. Okay, and when it is erected, it is real, not real, it is virtual. So according to our assumption, what is the result we got? The result we got is, we have assumed that M equal to minus HI by HO. We assumed this one, we assumed M equals to minus HI by HO by, so for a particular case of the object position, whatever the image we got, for those image height, object height, we have substituted the sign convention. Finally we got M value positive. M value positive means, theoretically it means that the image is erected and it is virtual. But what is happening actually in the diagram? It is not erected, it is inverted. It is, see, this is the head, this is the bottom, so upside down. This is inverted and it is real image. Why? Because actual reflected rays are meeting. If it is virtual, these reflected rays will not meet. These reflected rays appear to meet backside the mirror, but that is not happening in the diagram. So whatever assumption we have assumed, that is wrong. This is wrong. So which is correct? M equals to HI by HO is correct. This is correct. Then automatically this is correct. So you can check by taking this formula. Okay, you consider any case like object is B and C, or you move the object in between F and C. Okay, you can move the object in between F and C, draw the ray diagram. From the diagram, substitute the write the sign conventions, and these you substitute in magnification formula. This is, you will get correct answer. Why? Because, but out of all these things, you have to remember a common thing, that is, if M is negative, image is inverted and real. If M is positive, image will be virtual and erected. Okay, right? I hope you, whoever student has asked me, right, I think it is clear for that student, the doubt is clear for the student. And who are having doubts, the students who are having this doubt, so I think all of they have cleared on this concept. Okay, so please go watch our YouTube channel regularly, right? And you can ask me doubts. You make more and more subscriptions, which is, it will be very useful for the other students, like your friends, relatives, or whoever it is. Okay, so thank you for watching. Goodbye.